In this problem, we are to write the equation you would solve to determine when the ball hit the ground. Well, if the ball hits the ground, that's just another way of saying that the height above the ground would be 0. Then I will solve that to an accuracy of 2 decimal places using both the quadratic formula and my intersect feature. So doing so, replacing h of t, that whole output variable there, with 0, I will find the time value t for which it is a height of 0 feet above the ground. So it already has both conditions for me to use the quadratic formula. Condition number 1 would be that it's of the form ax squared plus bx plus c, and I guess you could think of it as a second condition that the one side of the equal sign has a 0. So in my problem, the coefficient on the squared term is negative 16. That would be a. The coefficient on the linear term would be b, which is 40. And my constant term, c, in my case 80, and I would proceed to plug those values into the quadratic formula, which was the opposite of b, plus or minus the square root of b squared minus 4ac, all divided by 2a, and again make sure that that division bar goes all the way across here. Now plugging those values in, I'm going to get, since b is 40, the opposite of b would be the opposite of 40, so negative 40. I'm going to start with doing the adding case, and that would be the square root of b squared, which is 40 squared in my case, because b was 40. Subtract 4 times a, which is negative 16, and then times the value of c, which was 80. And then all of that gets divided by 2 times the value of a, which again was negative 16. So on my graphing calculator, just having my calculator evaluate all of this, and generally you use the variable x, but in my problem, notice that the input variable of choice is not x, it is t. So when I solve this, these are the two time values in seconds for which the ball will hit the ground, meaning its height will be 0. So going to my graphing calculator, I'm going to type in negative 40. I'm going to do the plus case, and I'm going to have the square root. And then, because I'm in classic mode, I get a left parenthesis. I'm going to type everything that's supposed to be under the radical. And then when I'm done, I will do a right parenthesis. So I have 40 squared, subtract 4. And you can hit multiply by negative 16, or you can choose to put another set of parentheses, whichever you so desire. C was 80. Now, this is the place where I have to cap off that left parenthesis with a right parenthesis to let the calculator know that all of that was my radicand. All of that was under my radical. Now, I'm going to do this in stages by just pressing enter, and then don't forget that all of that needs to be divided by 2 times a. Make sure you put parentheses there, and doing so would look like this. Without the parentheses, the calculator will think that you're dividing just the 2, and it'll think of the negative 16 in the numerator, and you do not want that. So one of my answers is t equals negative 1.31. Remember, we are to round to 2 decimal places. So we have t is negative 1.31 to 2 decimals, and that would be the time value in seconds. So what this means is 1.31 seconds before the ball was thrown from the roof, it would have a height of 0. So to me, this does not make sense in the context of the problem. So I'm going to go back and I'm going to do the minus case now. So I'm going to retype this entire thing in my calculator except use a minus case. Let me show you on all of the calculators this can be accomplished by just pressing second enter, and that will type the last thing I did, and then pressing second enter again will type the thing before that. So I need not retype everything, I just need to edit what I typed before, left arrow over to the plus, and change that addition to a subtraction symbol. Press enter, and then divide that again by 2 times a, and again remember to put that in parentheses. So there is the numerator of my quadratic formula, came out to be a negative 121. And we're going to be dividing by 2 times negative 16, also a negative. So we should get a positive answer this time of 3.81, rounding to 2 decimal places. If you want, that is the t value. So t is approximately, I should be using approximately because I'm rounding. So the approximate solution to 2 decimal places is after 3.81 seconds, the ball will be 0 feet above the ground. This is when h of t would be 0. So 0 feet above the ground is just another way of saying that the ball hit the ground. Now the other way to have done this, of course, is to use graphing technology. So go back to my calculator, press y equals. You may have the equation in already if you followed the video in part A. I'm going to retype it in case you hadn't. And you can see on your screen the button presses that I'm doing. So make sure you type in the original equation. Notice that the calculator uses the input variable x always, even though I'd like it to be t. So once you get that in there, if I'm going to use my intersect feature, I want a reference line of y equals 0. That's a horizontal line through 0, and because my calculator has color, you'll actually see it being graphed in red. So your calculator, if it does not have color, you won't see it because it'll be a black horizontal line through 0, and your x-axis is already a black horizontal line through 0, so you wouldn't see it being graphed. So one of my solutions is a negative number. Here's that first intersection at negative 1.31 seconds. I don't want that one. I want the one on the right. So suppose I hadn't even done the quadratic formula. I still could have pressed second trace. Number 5, you can either down arrow to number 5 and press enter, or you can just press 5. Answer its questions. Is this the first curve, the parabola? Yes, by pressing enter. Is the second curve that red line y equals 0? Yes, it is. I'll press enter. And if I press enter right now, because this intersection is closer to my guess, it'll find that negative solution, and I don't want that one. So what I'm going to do is right arrow over, rightmost intersection point, and again, you can be a bad guesser. As long as your guess is closer to this intersection than it is to that, it'll find it. Now, the downside about this is sometimes students think this is the answer here, but that's just a guess. So you need to press enter, and make sure that it doesn't say guess, make sure that it says intersection. So this validates my claim that the y value will be 0, the height of the ball will be above the ground will be 0, after 3.81 seconds.